Thank you for the introduction. And hello, everybody. I'm, as mentioned, a PhD student of Justin in the lab of Environment and Exercise Physiology. And during the following couple minutes, I would like to introduce you to the test and intervention that we did. So briefly, what is main component of climbing performance? You can divide like different groups: body weight, age index, or performance of finger flexor muscles. The finger flexor muscles can be defined by three tests. First test is maximal strength of the muscle, then you have endurance test, and then you have oxygen kinetics test. So first test that I want to show you is the maximal voluntarily contraction, and on y-axis you can see force over time. We used hangboard with a 20 millimeter strong, and force over time looks something like this. So yes, this is the first test. Basically, our participants did two trials, and the highest value of MVC, or maximal voluntary contraction, was taken. The second test that you can look at are the endurance tests. So classical approach is to use time to exhaustion. But over past few years, we have a new method that's called all-out test. Yes, and during all-out test, you repeat 24 repetitions of 7 seconds pulling and 3 seconds resting. With this test, you can find out about three things, or we focused on three things. So first is the critical force. Critical force is actually, well, it can be characterized as muscle steady state. So it should be, in theory, covered only by aerobic metabolism. Second thing is total work. So basically, that's force of each repetition multiplied by time. It looks like this. That's the second thing. That's like aerobic and anaerobic components together. And the last thing is the work about the critical force. And in theory, those are the energy reserves of muscle. Last test, sorry, I lost my track. Last test that I want to focus on is the oxygen kinetics. You can use, yes, you can use ultrasound, or we use the near infrared spectroscopy, and that's basically when you apply a sensor on your forearm to focus on a specific finger flexor synergistic muscle group. And then we did 5 minutes occlusion test. So how does this test look like? Well, on a tissue oxygenation index over time, it looks something like this. Just to explain, tissue oxygenation index is the ratio between oxygenated and deoxygenated hemoglobin. So in the beginning, we had to measure the baseline. Then after measuring the baseline, we applied cuff, and cuff was inflated at 250 millimeters of mercury. And for 5 minutes, we had occlusion, and then after those 5 minutes, we had to release the cuff quite briefly. So you have cuff release, and then we measured time to recovery. 1/2 time to recovery is muscle oxidative capacity index. What does it mean? The better you have it, the faster reoxygenation of your muscle is, and then in theory, you have the better oxygen and blood distribution in your forearm. So about the training protocol modifications. Classical approach to training of your forearm is, it's high intensity, so it's around 70%. And it's basically 7 seconds of pulling and 3 seconds of resting. That is interesting, but it's like what everybody does, so we want to try something new. So we decided, this is tissue oxygenation index. And we decided to do a new method, and that is 2 seconds of pulling and 2 seconds of resting. What is interesting, why I didn't talk about tissue oxygenation index before, because here you can clearly see that actually it's quite different between those two interventions. And here in 2 seconds of pulling and 2 seconds of resting, the deoxygenation of the muscle goes lower than in the classical training. Why is that? We think that it's because, every time you contract your muscles of your forearm, you bring hypoxia to your muscles. So those 2 seconds that participants had time to rest were not enough to reoxygenate back like closer to the baseline. So the deoxygenation is a bit more. Well, basically about the study design. Before participants came to our lab, or like after they came to our lab for the first time, they filled in the questionnaire and they had their arms randomized. So this is important aspect of our study. Each participant was his own control. So one arm was 7 seconds pulling and 3 seconds of resting, and other arm was 2 seconds of pulling and 2 seconds of resting. Also, our participants were asked to fill in the training log. Well, in the first, we did the preliminary testing, so it's testing before the intervention. Then we did apply intervention, and after intervention, we did post-testing. Well, we had in total 15 participants. 11 of them were male, 4 female, and the average grade was around 7A, or in International Rock Climbing Research Association, 17. And the range was from 6B to 8A. And yeah, as I mentioned, is each participant's own control. So about the intervention, well, I basically explained that a little bit previously, but what I wanted to mention in this slide is that actually 7 seconds of load had only 6 repetitions, while 2 seconds of pulling had 21 repetitions. Why? Because we wanted to have the same load, same time. So like in both interventions, participants had to train or had to pull for 42 seconds. And yeah, it was 7 weeks long, and our participants trained for 3 times per week. Well, how did it go? Let's look at the results. So yes, the maximal force did improve significantly in both groups. But what we noted that it didn't improve significantly between the groups. Also, here you can see the critical force, which is supposed to be aerobic component or aerobic or force that is covered by aerobic metabolism. And this also didn't improve significantly between those 2 groups. Yes, in the blue box, you can see 7 to 3 intervention, and in the orange box, you can see 2 to 2 intervention. Sorry for this corner. And max, okay, I went back. And total work also did improve, but again, it didn't improve significantly between those 2 groups. However, what improved significantly between those 2 groups was time to recovery, or half time to recovery. And this is the muscle oxidative capacity index. So basically, with 2 to 2 protocol, our participants improved in oxygen distribution in the muscle. In conclusion, what did improve? Yes, maximal contraction improved, total work did improve, then also critical force did improve in both interventions, but only time to recovery improved in the 2 seconds of pulling and 2 seconds of resting intervention. In conclusion, I wanted to mention that it's quite interesting to implement these 2 seconds of pulling and 2 seconds of rest into the training routine. And also what is interesting that with classical approach to rock climbing research, while you are using only hangboard, we wouldn't find out about those results because we needed to use more advanced physiological methods. Well, thank you for showing up during this beautiful sunny day. Thank you for your attention. And if you have any questions or discussion, please.
Thanks a lot, Tomáš, for that great presentation.
Daniel.
I have a question. Do you think that this half time to recover improved because this saturation of muscles, or I'm not physiologist, but there's these two interventions. There was a gradual decrease in saturation in muscles.
Yes, it's a gradual decrease because the muscle is that doesn't have enough time to reoxygenate. So like when you don't have enough time to reoxygenate and you actually get less oxygen, then you need to improve a little bit for this. So like I think that either like capillaries or the blood distribution or something changed. Like we didn't analyze what exactly they changed, but the time to recovery did improve.
Thanks. Who else?
Thanks.
What are the kind of, so you didn't see any change in critical force, MVC, or?
Sorry. I did mention that we did see change, like it improved.
Yeah, but not between the two protocols.
Yes.
So what would be the, you saw an improvement in the half time to recovery?
Yes.
How might that manifest itself in terms of improvements in performance, or does that not matter if we're seeing the same? So essentially, you've taken the power duration or talk time relationship, you divide it into three components: MVC, W prime, or time above critical power and critical force. Now, they almost dictate our ability to perform, and then you've taken another measure. That maybe how does that measure that you've taken the half time to recovery relate to our ability to perform or ability for the forearm flexors to perform?
Well, it was still a 7-week-long intervention study, but if you improve oxygenation, at some point you will also improve the other parameters. But so far it's not. Well, it's not shown significantly. Like if you take a look back, not this one, but there are some results that are closer to be significant. However, they are still not.
So you're saying it's the first step towards improving critical force. You need to take that step physiologically first before you can increase critical force later down the line.
Possibly.
Okay, thanks. One last question. Yeah. Okay.
How did you choose the time that the 42 minutes repetition?
42 seconds.
What?
42 seconds.
It is how you choose this.
Well, we wanted to maintain the equivalent load. So, like, if you pull for 6 repetitions for 6 repetitions with 7 seconds, then if you pull for 2 seconds, then you also need like to have equivalent load. So basically, you just divide 42 by 2, and you get. Or maybe I didn't understand the question.
I think it was why 42 and not more or less.
What?
Why 42 and why not more or less?
Yes, for example, in the test with 700 test, if you had it more times, maybe the oxygenation will start to get lower. So
Possibly, but we looked into the literature and we found out that usually people in climbing research use this protocol. So we wanted to stick to the traditional one and then find something new, or like try a new one.